Welcome to the tour guide training, led by Alison Bronson.
Hi.
Dr. Bronson,
That's good.
covering Science B,
Yeah,
scan and electron microscopes,
to a degree.
and
Oh, I'm supposed to, okay, and
Yep.
we're going to go see the anatomy lab, and we're going to talk about the Vertebrate Museum a little bit.
ooh, excellent.
So,
All right,
yeah.
on to the next spot.
Right, so the hub's-beaked whale, if you guys ever forget when you're giving a tour, it says right there, hub's-beaked whale. Okay, so over the summer I had an internship in a museum in New York, and they had this big whale exhibit that was traveling through there, and our tour guide for the whale museum tour thing, who showed us like all these different whale skeletons that were in this museum, he said that beaked whales are really, really rare, so they live in super deep water, and so we don't see them very often. So I didn't realize that until this summer, and then I came back and I was like, that's so cool, I have a beaked whale. So this one's female, the males have a really big, like, tusk, like, hump in their jaw.
Wow.
So
Classic cameraman move.
so, do you guys know how this whale died? Does anybody follow along with your
Yes. It has an ear infection,
Right.
so it got trauma afterwards.
Yeah, so it basically didn't understand what that was at because I had ear infection. So it washed up on the beach. And where did it wash up? In Humboldt County. So when a whale washes up here, students get to go out and dissect it and find out how it died. And then they bury it under the beach. So that's one way of getting the flesh off of specimens, right? And then our other way is, right, we have our own domestic beetle colony.
And just for reference, we don't have to say the African part, just because.
It's just extra information.
Yeah, and I think a lot of people get a weird assumption about Africanized bees, African flesh-eating beetles.
They're invasive.
Yeah, it's just they're just flesh-eating beetles that happen to be from Africa. Yeah.
Yeah, so they're we are really careful about not letting them out in the environment, but they don't go after like living flesh. So when you're putting something in there, you just pick up the carcass and put it in there, and then when you're done, you pick it up and shake it off and take it out. So the advantage to having those instead of hi Terry. Terry's our mycology professor, for those of you who don't know who that is. Hi Terry. So,
Terry's on a mission.
Terry's been here all day. I saw him really early. So he goes to the Guiana Shield in South America. Looks for fun.
Oh yeah.
How cool is that, right? So okay, so what was I talking about? Beetles, they're gross. Okay, so you can also boil the flesh off of bones, but that also gets rid of the connective tissue. So the advantage to having a beetle colony on campus is if you want to have articulated skeletons like put together, like for the Vertebrate Museum, they leave a lot of that tissue behind. So like if I put a big dead fish in there, when I take it out, most of the bones are still articulated in the way they would have been on a regular skeleton. So you're not left with like a pile of really, really tiny bones and you don't know where any of them go. And you'll see more tiny bones in the anatomy lab a little later. So, yeah.
Why the hubs beaked whale? What is hubs?
Carl Hubs.
Okay.
Yeah, so that was a prominent marine biologist, Dr. Carl L. Hubs. Named it after him. Yeah, so there's this giant book called the Code of Zoological Nomenclature. You can't name stuff after yourself. It's a rule that you can name stuff after other people. So, they named it after it.
Here, you discovered it, named it after me.
Well, Allison has a creature named after her. It's called the Brontosaurus.
I did get to name something though.
Oh, that's right. And you named it after.
Two people. So I got to name a fossil fungus, and it's called Spataporthy taylori.
Wait, did you just say you got to name a fossilized fungus?
Yeah.
How many undergrads get to do that?
At HSU, a handful. In the lab that I work in, we actually have quite a few undergraduates that have described species and entire families. Christine Bach described a whole family of liverworts, APAC. So, yeah. Ooh, undergrad research. So that was named after two people. So Zoe Spataphora is the Spataphora part. And then on Taylor, fossil mycologist is the Taylorite part. So you can name it after other people, like Carl Hubs, but not yourself, a giant bummer. So let's go out Science-y and we'll look at another whale. So Tor Holmes runs the Vertebrate Museum. Tor recently had a critter named after him. You guys remember which critter?
The shrew.
Yeah, the shrew. Good job, Sean. So Tor's hero shrew. We actually have alumni working all over the country. Yeah, so someone who studied here at our Vertebrate Museum and now works in the Field Museum remembered Tor, and when he found this vertebrate with the strongest spine for its size of any living vertebrate, he named it after Tor. Strong guy. So it's vertebrae, and here's some whale vertebrae over here. There's basically only has a couple of processes on it, right? Top and the bottom. So the shrew has a bunch of extra bony processes on the sides of its vertebrae, and that make it super, super strong. So like the story is, they're out in the field, maybe asked some locals like about cool critters in the area, and they said, "Oh, you've got to see this shrew." And so they picked it up and they throw it on the ground, and a guy would like stand on it, like bounce a little bit for like a few minutes, okay, and then they'd get off, and the shrew was fine, and it would run away. So they're like, "That is amazing. Wow. We need to describe this for science." So, as biologists do, right? So now there's Tor's hero shrew. So the Vertebrate Museum. Anybody tell me about the Vertebrate Museum? Do we have a lot of specimens in there?
Lots.
Yeah, lots. What's the size relative to the other CSUs?
Largest.
It's the largest. It's actually one of the largest in California. We have over 15,000 specimens in there. And then right behind you, what critter is this?
Sperm whale.
Whale. Good. What part of the whale?
Top jaw.
Yeah, can you describe to me how things are kind of oriented in here?
It's flipped upside down.
It's not flipped upside down.
It isn't?
Please do not tell people that this is upside down. This is whale, guess part of the cranium is worn away, but this
Watch
is
out,
right
Reggie.
side up. So they don't have teeth in their upper jaw, so I know it can be kind of confusing. They do in their lower jaw, which you can actually see over here. Okay, so here are holes for the teeth. They're the largest toothed whale.
That's the lower jaw.
Mm-hmm. Yep. So there's the lower jaw, but sperm whales have this huge hollowed out space in their head, and that was filled with this substance called spermaceti, which was really, really valuable to whalers. They're one of the most heavily whaled species. But yeah, this is not upside down. It's not like the lower jaw or whatever. This is the upper jaw.
And it's
space for brain gunk and spermaceti. So
this is the top of its skull then, basically.
yeah. So this is like, if you were to take our skull, pull off the lower jaw, do this. Yeah. So Tor said that was a particular pain in his butt, was people saying it was upside down. So he was like, "Stop saying that." I was like, okay. So I thought we'd clarify, because it totally looks weird, right? This is not something that's easy to relate to our heads. So this is a dissecting table, and they put giant dead things on it, like pinned heads and smaller cetaceans, like a pilot whale or something, might just sit up there. Yeah, that's the largest part of the Vertebrate Museum. There's mammals, but it also has reptiles, some amphibians, and some birds. The mammal portion is the Tim Lawler mammal collection, and he was here for, I think, over 30 years. He taught here. So there's a lot of students all over the country that are basically like Tim Lawler alumni. And so we had a big dedication thing a couple of years ago, and everybody came out here and talked about Tim and like cried a little bit, and it was really cute. And it was just amazing, like all the different people they had talked to. So he had students, at the Smithsonian, at the Field Museum, and the American Museum in New York, all here. Yeah, pretty cool. They learned all their stuff here, and they took it all over the country. So, yeah. This is e-waste. Please remove. Okay, it's just like some printer. These are minke whales. If you guys want to show your tour takers gray whales or gray whale skulls on the outside of this building on the other side, right outside the mammalogy lab. And then, here. Yeah. So down here, my key stopped working, and Casey went home. Dad was having some trouble back home, so he just
That was wonderful.
took off for the night. But that room, 105, goes to that new environmental scanning electron microscope. So that dark, scary hallway. And then over here is part of the collection section of the Vertebrate Museum. If you go up that way, there's more of the Vertebrate Museum, You guys can see we have some cool ungulates on the wall up there. And that big whale fin right there is actually articulated by some friends of mine. I believe that was a gray whale that washed up on the coast, but I'm not totally sure. I have a great picture of my friend standing there just in these coveralls covered in just gunk with a shovel, grinning. There's a big dead whale behind her. She just looks stoked. This is a person that like normally wears like aprons and makes me cupcakes and stuff, so it's like an extra awesome picture. But yeah, so if you guys are ever interested in Vertebrate Museum stuff, Tor is awesome. He's a guy with a big gray beard and various mammal shirts and tie-dye. He's the best collection of vertebrate shirts, I think probably in like the Western Hemisphere. But he's just astoundingly helpful. Like we stopped by the other day and he showed us all around the collection and discussed with us the importance of being kind of anal retentive if you're in science and just being hyper organized about everything. So that was cool. He's also a good storyteller.
Yeah.
Nice. Yeah. He has a talk for mammalogy in the fall, and like people from all these classes just show up to hear him talk. Like I went last semester and there were like a dozen extra people in there. Yeah. Oh, you guys can smell the beetles probably. Scanning electron microscopes do. They take pictures of the surface. So this is inside of cells, and I'll talk about that in a second. But they take pictures of the surface of objects, and I'll show you some more pictures over there. But they fire electrons at the surface of your specimen, and the way those electrons bounce back gives you an image of the surface. So you can magnify things thousands and thousands of times. I was just in here a couple weeks ago magnifying a Newton nose 16,000 times in there, so you can see really fine details of cells. Like we're looking at tiny cilia that come out of the top of them. But these are open for undergrads of any major. So you don't have to be like a biology major or whatever to use them. In fact, so Marty, who runs basically like the upkeep for all of those SEMs, including the new one, he likes to like sit in there and hang out when you're looking at stuff and give you advice on how you messed up the contrast or messed up the focus. He said that his best student in that scanning electron microscopy class was a film major. And she actually had some biology background. Nobody like knew anything about it, but she was a film major, and she was literally setting up images for films inside the SEM. So she'd make really small scenes, basically, and film them in there and put together films from that. And he said she was just the most meticulous, detail-oriented person he'd ever met. So any major is totally welcome to use these. For the old school ones, which are just down the hall, you sputter coat the specimen. So first you dry it, you use liquid CO2, and you infiltrate it with liquid CO2, and then you rapidly dry that off, and so you have this little crusty, dry specimen, and then you put that in the sputter coater, and it sprays gold over the top of it in a really fine mist. So that gives you a reflective surface, and when you're missing that surface, you're basically like slowly burning holes in your specimen. So, and you can see that actually if you're looking in there and you've had the beam, the electron beam on an area too long, it makes a big dent. It literally like burned the hole in your specimen. So just put dead things there. Things you want to be dead, I guess. But yeah, so the ones down there, you have to sputter coat things, and so that's actually, our sputter coater is located in the room with them. Those you can take pictures with. You have to kind of like, there's a camera set up where you have a digital camera wired to it. But what's nice about this, the new SEM, the environmental one, down the hall, nice, is you don't have to sputter coat things to put in it. And it's also been really useful in both analyzing, to some degree, densities and also the mineral composition of geological samples. So geology, geochemistry can use that for their work, as well as biology, wildlife, fisheries. Anyone that's really interested can use it for their research. There's a whole class that Casey Glue teaches. So Casey Glue's the one that failed a little early today, and I was like, no, my key doesn't work. So Casey teaches an entire class that's scanning electron microscopy, and also transmission electron microscopy, and that's where you get images like this. So this is a mitochondrion right here. You guys should come over and check it out. But here's a picture of a mitochondrion. Okay. And so the TEM shows you the inside of cells. So if you want to see particular organelles, which is all of these pictures, and here, and these, we have a transmission electron microscope for that. So SEM, scanning electron microscope, the surface, you can think just like scanning the surface, or SEM, surface starts with S. TEM, transmission electron microscope, transmit through it so you can look inside. That's the way we remember which is which.
Are these the only three here, or are there some in the astronomy building, or physics building?
There aren't any in
chemistry building?
Science A.
Okay, cool.
No. So there's a nuclear magnetic resonance lab in there, and that's about molecular vibration. And then we also have the spectroscopy devices, so infrared, gas, and mass spectroscopy.
Okay.
But in here is where the 3 scanning electron and 1 transmission electron microscopes are. And this is actually the room with the TEM and where they prep everything for that. So there's a microwave in here. You can actually process your samples faster if you microwave them, which is pretty funny. So all kinds of cool things in there. And it's like super toxic and like radioactive and stuff. Yeah, do not bring your food in there. But there's food in here. This says ant cages, but it's really coffee table supplies. So the biology students, the graduate students run a coffee table. You guys probably bought coffee out there. So the department matches that funding, and that's for talks on Fridays. So tomorrow there's one at 4. So here's some more of those TEM and SEM images. This is urchin pedicularia. They have in between their spines little arms that reach out and pinch stuff. That's an image of those. I wanted to point out over here, in case you put this up, these are, the round portions are little algal cells, and the things around them that are lighter brown are little fungal filaments. We call them hyphae.
They get hyphy?
Yeah, exactly. So when algae gets real hyphy, it becomes a lichen. So this is actually one of the earliest anatomically preserved lichens ever found. It's about 136 million years old. Wow. It's from the Cretaceous. And Kelly Matsunaga, who's a student in Mihai Tomescu's lab, was an undergraduate when she published this in the American Journal of Botany. And now she's one of his grad students working on stuff that's not anatomically preserved, so it just looks like a bunch of steaks, basically, and she has to deal with its compressed material. But this is anatomical preservation, and using the SEM, she was able to magnify this enough times that, see where that little white arrow is, indicating that filament that's poking into the algal cell? That's the point of the fungal algal interface, basically. So where the fungi is actually contacting those algae to draw out nutrients for them. So the algae essentially gets a place to live, gets some protection from desiccation, drying out, and in turn the fungus gets a bunch of photosynthase from the alga. So she actually was able to pinpoint where those two came together and describe the kind of contact that they had, because she was able to use one of our SEMs to look at her fossil. So I just think that's a super cool example that also made it to the American Journal of Botany, which is like so super awesome. It's like Science and Nature and then American Journal of Botany right after that for botanists. Pretty impressive. Yeah. Soon. Yeah. So the second floor is great because this is where the biology department office is. If you have bio majors on your tours, you can send them up here. Bruce O'Gara said today that about 1,200 students on this campus are biology majors. So, and marine biology and zoology are the largest majors on campus. We have 3D reconstruction software, something you can tell your tour takers, and we have a bunch of microscopes that you can use, a bunch of chemicals, you don't have to tell them that. And we also have a 3D printer, which is awesome. Yeah. Anthony Baker just gave my friend a 3D printed cat. That's like that big. She was just like that 3D printer actually, so Anthony's really stoked on cross-departmental work. So art students have actually worked with him on that.
Can you use that 3D printer for your own personal use?
For your own personal use?
Yeah, or just for like school purposes.
Like to make a toothbrush or something?
Yeah.
So Anthony's a guy to talk to, but he's pretty much stoked on using it for anything. So, like he printed a cat, for goodness sake. So they're definitely trying to get a lot of use out of it. I know he wanted to collaborate with some art students, but if you have a particular idea for something, you'd probably be pretty darn open to it. Yeah. This is also where you bring your waste jars. So this is our hazardous waste area. This nice danger room contains multiple classes of chemicals and compressed and liquefied gases. It's also where I think it's the biggest fume hood that we have is located. Yeah. Like when we acid process diatoms in Frank's class, they do it in here. Yeah. Do you have any questions on the bioreactor facility? Animals in it. So like here's some pelvic and pectoral girdles of sharks here, and then here's a cranium of a shark. So that's this class that's taught in this room where you go through all the vertebrates. So you start from sea squirts, which are actually really close relatives of the vertebrates. They're urochordates. So you start with little sea squirts and look at them in their larvae. You look at lampreys. Do you guys know what a lamprey is?
Yeah, the section.
Yeah, it's a jawless fish, and we have a tub of them. Maybe I'll take one out if we have a minute. So we have lampreys. Then you look at cartilaginous fish, like these sharks, and then you look at bony fish, like this amia here. So both the basal, like amiformes, basal fish, and the higher teleos. I'll show you some more of those. Then you look at reptiles and amphibians, well, amphibians first, and then reptiles and birds. And then you look at cats and rabbits for your mammals. And then you also look at people at the end of the class. So all of that is in one semester. And the idea of the course is that you're basically able to look at a structure in one group of animals and compare it to something in the other. So you know which things are related evolutionarily speaking. So it's a really useful class. And it also stands out a lot that we have that course here. I was visiting the University of Chicago, and they don't go through nearly as many animals as we do here. And I thought that was just really interesting that we're a small university, but we have a lot of cool stuff to look at.
What class is that?
Comparative vertebrate anatomy. It's only offered in the fall if you guys want to take it. Yeah, so John Rice, who teaches it, is right now on his sabbatical in Argentina looking at South American frogs, which is super cool. And I miss him because he's my research advisor. But he'll be back a couple days before graduation. He had to be here for all the parties, so he's coming back. And then in the fall, he'll teach it again. So he's actually really excited. He was department chair for quite a few years. And so when his 3 years were up, he's like, yes, I get to teach. And this is the first class that he offered. Nice. So let's look at this stuff right here behind the screen, because here's some cool things I can show you. So this right here is Nectarus, which is a really large salamander. And when I was talking about those processes that we see on the vertebrae of that shrew, see how there are these processes on the sides here? Mm-hmm. Picture those like quadrupled. There are a lot of them in there, and that's a lot what that shrew's vertebrae skeleton looks like. Yeah, so that's Nectarus. But back behind this inconveniently placed screen, we have all kinds of cool stuff. Well, here's a really sad amia, but here's a larger teleos skull. So they have special bones that make them different from other fish. So, like they have a premaxilla here in front of their maxillary bone. That's a bunny. We have some cats on the other side, and there's a chicken down there, sturgeons. This is this is a shark in a jar. Pretty
Shark in a jar.
A shark in a jar.
Whoa,
Yeah.
shark in a jar. My favorite kind of shark.